In the early 1960s, the Earth was quiet. Not peaceful, just quiet in a different way. No explosions echoed across continents. No armies marched across borders. But something far larger was unfolding above the planet. A silent competition, a race not for land, but for the sky. The United States and the Soviet Union were locked in a struggle that went far beyond weapons or territory. This was a battle of ideas, of influence, of perception. Whoever reached space first would define the future. And for a brief moment, the United States was losing. In 1957, the Soviet Union launched Sputnik, a small metal sphere barely larger than a beach ball. But when it began to beep from orbit, that sound echoed across the world. It was proof that the Soviets could reach beyond Earth, proof that American skies were no longer untouchable. Fear spread quietly, not panic, but unease. Because if they could put a satellite in orbit, what else could they put there? Then came Yuri Gagarin. In April 1961, he became the first human to leave Earth and return alive. One orbit, one smile, one sentence that shook an entire nation. "I see no God up here." The message was clear. The Soviet Union was ahead. America needed a response, and it needed one fast. Only weeks later, President John F. Kennedy stood before Congress. His words were calm, measured, but history would remember them as a challenge. "We choose to go to the moon," not because it was easy, but because it was hard. That single sentence transformed NASA overnight. The agency was no longer just a scientific organization. It became a national symbol, a promise, a ticking clock. Before Kennedy's speech, NASA was cautious. After it, NASA was urgent. Deadlines appeared, schedules tightened. Failure was no longer just a setback. It was a political embarrassment, a strategic weakness. Every delay mattered, every launch was watched, and every mistake carried consequences far beyond engineering. The Mercury program proved that Americans could survive in space. The Gemini program proved they could maneuver, dock, and walk outside a spacecraft. But Apollo was different. Apollo was everything at once. A spacecraft, a launch system, a life support environment, a return vehicle. And most importantly, Apollo was supposed to land humans on the moon and bring them home safely. All before the decade ended. Engineers worked around the clock. New technologies were invented faster than they could be tested. There was no manual for this, no historical reference. Every decision was, in some way, an educated guess. Most of the time, those guesses worked, and when they did, confidence grew. Perhaps too much. Inside NASA, two forces began to quietly compete. One was safety. The other was schedule. Both claimed to serve the same goal, but they did not always agree. Engineers raised concerns. Managers weighed risks. And somewhere between caution and ambition, small compromises were made. Not out of carelessness, but out of belief. Belief that the system was strong, that problems were manageable, that nothing catastrophic would happen during a simple test. After all, This wasn't even a flight. By 1966, Apollo hardware was taking shape. The command module looked complete, the systems were integrated, and the next step was obvious. Put astronauts inside. Test everything on the ground. Apollo 1 would be the first crewed mission, or more accurately, the first crewed test. There was no launch date, no destination, no danger, at least on paper. The astronauts would sit inside the capsule, run through procedures, and prove that the spacecraft was ready. A routine step, a necessary step, a safe step. That assumption would change everything. As the decade rushed forward, NASA felt the weight of time more than ever. 1967 was supposed to be a year of progress, a stepping stone toward the moon. Instead, it would become a year of reflection, a pause, a reminder that space does not forgive haste, and that sometimes the most important lessons are learned before leaving the ground. Before the fire, before the silence. There were 3 men, not symbols, not headlines, just men who trusted the system they were asked to enter. They were not reckless. They were not unaware of risk. They were astronauts, and risk was part of the job. Virgil Gus Grissom had already been to space. He was one of the original Mercury 7, a test pilot, calm under pressure. He was known for being direct, sometimes blunt. If something didn't feel right, he said it. That honesty earned respect, and sometimes friction. Gus Grissom had seen spacecraft fail before. He had survived it, and that experience made him cautious. Edward Higgins White II was different. Quiet, focused. He became the first American to walk in space. Floating above Earth, tethered only by a thin line. To the public, he was a hero. To engineers, he was disciplined, precise, methodical. He trusted procedures, and procedures had always brought him home. Roger Bruce Chaffee was the youngest. This would have been his first spaceflight, but he was not inexperienced. He had trained for years, served as a communications expert, understood spacecraft systems deeply. Other astronauts trusted him. That trust is never given lightly. Together, these 3 men formed the Apollo 1 crew. They were not strangers. They trained together, argued together, laughed together. They knew the spacecraft better than almost anyone else, and that knowledge came with concerns. The Apollo command module was impressive, compact, complex, filled with switches, wiring, panels, and controls. It was designed to support life in the vacuum of space. But inside, it was crowded. Cables ran behind panels, Velcro strips held tools in place, plastic and fabric lined the interior. Nothing seemed unusual, until you considered the environment. The cabin atmosphere was pure oxygen, 100%, at ground level pressure. In space, this wasn't as dangerous. But on Earth, pure oxygen changes everything. A spark that might normally fade becomes a flame. A flame becomes an explosion. The astronauts knew this. Engineers knew this. But the risk was considered acceptable because it always had been before. There was another concern. The hatch. It opened inward. It required several steps and time. In an emergency, pressure inside the cabin would push it closed. This had been discussed. Notes were written, concerns logged. But redesigning the hatch would delay the program, and delays were expensive. Gus Grissom was not comfortable. At one point during training, he joked,
How are we supposed to get to the moon if we can't even talk between two buildings? The comment referred to communication issues, but it reflected something deeper. The spacecraft wasn't perfect, and everyone knew it. Still, the test approached. January 27, 1967. This was not a launch. There would be no rocket fuel, no ascent, no orbit, just a simulation. The astronauts entered the capsule in the afternoon. They were calm, professional, focused. As the hatch closed, the oxygen flowed in. Pressure increased. The air became invisible fuel. But no one thought of it that way. Not yet. Minor problems appeared. Static in the communication lines, muffled audio. Annoying but not alarming. Engineers worked to resolve it. Time passed. The astronauts waited. Inside the capsule, nothing felt dangerous. No shaking, no countdown, no acceleration. Just routine. That sense of normalcy was deceptive, because the most dangerous situations are often the quietest ones. The men inside trusted the machine. The engineers trusted their calculations. Management trusted the schedule, and the schedule did not allow fear. What happened next would unfold faster than anyone could react, and when it was over, the Apollo program would never be the same again.
January 27, 1967. It was a Friday. At Cape Kennedy, the day felt ordinary. No crowds gathered, no cameras pointed skyward. There would be no launch. Just a test, a rehearsal. Something NASA had done many times before. The astronauts arrived early. They followed the same routine they always did. Medical checks, briefings, equipment verification. Nothing felt unusual. Nothing felt urgent. By mid-afternoon, Gus Grissom, Ed White, and Roger Chaffee climbed into the command module. The spacecraft sat on Launch Pad 34. It was connected to the ground by cables and umbilicals. Power flowed from outside. The rocket below was unfueled. This was supposed to be the safest configuration possible. As the hatch was sealed, the atmosphere inside the capsule changed. Pure oxygen filled the cabin. Pressure slowly increased. This was standard procedure. No alarms sounded. No warnings appeared. The test began. The goal was simple. Simulate a launch countdown. Run through every step. Check communications. Check power systems. Confirm readiness. Everything on paper. But almost immediately, small problems began to surface. The audio system crackled. Voices cut in and out. Words were lost in static. It was frustrating. Not dangerous, but frustrating. Engineers in the control room worked to resolve the issue. They adjusted settings, switched channels, asked the crew to repeat themselves. Minutes passed, then more minutes. The schedule began to slip. Inside the capsule, the astronauts waited. They were strapped in, unable to move freely, surrounded by switches and panels. The temperature slowly rose. The oxygen-rich air felt dry. Still, nothing seemed wrong. At one point, Gus Grissom voiced his irritation. "How are we going to get to the moon," he said, "if we can't communicate between 2 or 3 buildings?" It was half a joke, half a warning. The test continued. Time passed. The clock moved closer to evening. At approximately 6:31 p.m., something changed. No alarm preceded it. No warning light appeared. Just a sudden, sharp call over the radio. Fire! At first, no one fully understood. Fires were not expected. Not here, not during a ground test. Then another voice. Fire in the cockpit! This time louder, urgent. The calm tone was gone. Inside the capsule, a spark had ignited. The exact source would later be debated. Damaged wiring, a short circuit. In normal air, it might have fizzled out. In pure oxygen, it became instantaneous. Flames raced across the interior. Materials that barely burned became fuel. The fire did not crawl, it exploded. Pressure inside the capsule surged. The temperature rose in seconds. The men tried to escape. They reached for the hatch, but the pressure forced it inward, sealed, locked by physics. In the control room, engineers watched in horror. Telemetry spiked. Readings went off scale. Communications dissolved into noise, shouts, then nothing. The entire sequence lasted approximately 17 seconds. 17 seconds from the first word, fire, to complete silence. Ground crews rushed toward the capsule. Smoke poured from the spacecraft. They struggled to open the hatch. The heat was overwhelming. The oxygen-fed fire had already consumed the interior. When the hatch was finally opened, the truth was undeniable. The astronauts had not survived. There was no explosion heard miles away, no dramatic fireball, just a quiet, devastating end. On the ground, before flight. The test that was never supposed to be dangerous had become one of the darkest moments in NASA's history. And in the stillness that followed, questions began to form. How could this happen? How many warnings were missed? And what would it cost to make sure it never happened again? 17 seconds. That was the length of time between routine and catastrophe. Not enough time to react. Not enough time to think. Barely enough time to understand. Yet, in those 17 seconds, everything changed. Inside the capsule, the fire moved faster than human reflex. Pure oxygen fed it instantly. Flames leapt across surfaces that were never meant to burn. The interior became unrecognizable. The temperature rose so rapidly that survival became impossible almost immediately. There was no slow struggle, no drawn-out escape attempt, just a sudden, overwhelming force that left no margin for error. The astronauts tried to open the hatch. This much was clear from the evidence. Their final movements were not panic-driven. They were procedural. They did what they had been trained to do. But the laws of physics were against them. The pressure inside the cabin had risen beyond what the inward opening hatch could overcome. The hatch became a wall. In the control room, confusion spread. Telemetry values spiked violently. Some readings exceeded their maximum limits. Others vanished altogether. Headsets filled with noise. Then silence. Engineers stared at their consoles, unsure of what they were seeing. Some thought the sensors were malfunctioning. Others feared something far worse. No one wanted to say it out loud. Outside, ground crews ran toward the capsule. Smoke poured from the spacecraft. The smell of burning insulation filled the air. Heat radiated outward. Opening the hatch was difficult even under normal conditions. Now it was nearly impossible. When the hatch was finally opened, there was no urgency left, only confirmation. The men inside were gone. Word spread quickly but quietly. There was no public announcement at first, no press conference. NASA needed to understand what had happened before it could explain it or accept it. That evening, the launch pad stood still. The rocket beneath the capsule had never been ignited. Yet lives had been lost. Not to space, not to re-entry, but to a system that failed where it was supposed to be safest. The next days were heavy. Meetings filled conference rooms. Engineers replayed data endlessly. Every wire, every material, every decision. Nothing was beyond scrutiny. NASA established a review board. Its task was simple in theory: determine what happened and why. In practice, it would become one of the most painful investigations the agency had ever faced. The findings were not comforting. There was no single cause, no lone error, no individual to blame. The tragedy was systemic. The fire was fueled by pure oxygen. The materials inside the capsule were flammable. The wiring was vulnerable. The hatch design prevented rapid escape. Each factor alone might not have been fatal. Together, they were. But perhaps the hardest conclusion was not technical. It was cultural. Warnings had been raised. Concerns had been noted. But the schedule had spoken louder. The pressure to move forward had slowly dulled the instinct to stop. This realization was devastating, because it meant the tragedy was not unpredictable. It was preventable. NASA faced a choice: minimize the loss, or confront it honestly. To their credit, they chose the harder path. Crewed Apollo missions were halted. The program paused. Time, the very thing NASA had been racing against, was finally given space. The silence after Apollo 1 was not empty. It was filled with reflection, with humility, with the understanding that spaceflight demands respect at every level. The 17 seconds of fire had burned away assumptions. What remained was the responsibility to do better. And that responsibility would shape every decision that followed. The loss of Apollo 1 forced NASA to do something rare: stop. Not slow down, not adjust the schedule, but truly stop. For an agency built on momentum, this was difficult. For an agency under political pressure, it was painful. But it was necessary. For nearly 2 years, no American astronauts flew into space. Instead of launches, there were meetings. Instead of countdowns, there were questions. And instead of progress headlines, there was silence. The Apollo command module was taken apart, not symbolically, physically. Every wire was examined, every material tested, every assumption challenged. Nothing was sacred. The pure oxygen environment was eliminated for ground tests. Flammable materials were removed or replaced. Velcro, once convenient, became a liability. Wiring was rerouted, shielded, redesigned. The spacecraft became heavier, more complex, but safer. The hatch was completely re-engineered. It would now open outward. It could be opened in seconds. No tools, no delay. Escape would never again depend on luck. But the most important changes were invisible. They happened inside the organization. Engineers were given stronger authority. Concerns could no longer be dismissed as delays. Safety reviews became mandatory, not optional. If someone said, "Stop," the program stopped. Apollo 1 changed how NASA listened, not just to data, but to people. When crewed missions finally resumed, they did so under a new philosophy. Spaceflight would always be dangerous. But danger could be understood, managed, respected. In October 1968, Apollo 7 flew successfully. Then Apollo 8 circled the moon. Apollo 9 tested lunar hardware. Apollo 10 rehearsed the landing. And in July 1969, Apollo 11 touched the surface of the moon. Those footsteps were not just a triumph. They were a continuation. Because without Apollo 1, there would have been no Apollo 11. Every astronaut who walked on the moon carried the legacy of 3 men who never left the ground. Today, Apollo 1 is not often mentioned. It has no dramatic footage, no iconic images, no moment of celebration. But its impact is everywhere. In spacecraft design, in safety culture, in the quiet moments where someone chooses caution over speed. Progress often celebrates success, but it is shaped by failure, by reflection, by the courage to admit mistakes. The fire of Apollo 1 lasted seconds. Its lesson has lasted decades. And in the long history of space exploration, perhaps that is its greatest contribution. Not how far it went, but how deeply it changed us.